Hey, hi Dipanshu. Thanks for joining. So I guess we are good to go. So before we start, I would like to just introduce Adish. He's been with us from the very start. He's been a design partner with us. So after, just let me show you about the agenda. Great. So it won't be just OLake presenting, but we have a special guest with us. He will also be presenting about how he used OLake in the setting that he had, the physics solar setup, and then how OLake as a product
Priyank,
matured in. Yeah.
sorry to interrupt. Your voice is a little bit breaking.
Okay, just give me 1 second. Okay, is it good now? Am I audible to all of you? Yeah.
Yes, it's still breaking though.
Okay.
Yeah, I think you can continue now. Maybe it minor internet hiccup.
Yeah, maybe for that reason. Okay, we have all the folks joining, so let's wait 1 more minute for all of them to join. We got Battle. Yeah. Great. So yeah, I formally welcome all of you to our sixth community meetup. Uh, sixth. Let me just turn this on for now. Your sixth community meetup. We have held our. Let me go back. Yeah. From the start, we did our second community meetup, third meetup, fourth meetup, fifth meetup, and the build-up. Right now, we are at our sixth community meetup. In the past few meetups, we showed you that we are building a new Postgres connector, we are building a new MySQL connector. Then we showed you in our previous meetups that the Iceberg partition or the Iceberg writer is live. And in this meetup specifically, one of the major announcements that we're going to make is that Iceberg partitioning is now alive at OLake. You can just test it out, go to our repos, check out the documentation. So this has been the highlight. Other than that, we are happy to announce that we support Hive, REST, JDBC catalogs as well, fully supported. The docs for them will be in the documentation section. Other than that, the new feature that we announced was how to set up OLake on Kubernetes. You can just go and set up how to run it as a cron job or a Kubernetes operator. So this has been a major development from our side. The developers at OLake were busy this last month preparing all the features for the community. And if I talk about why this features is required, so why someone will need Iceberg partitioning. So if you have terabytes of data or even hundreds of terabytes of data, partitioning is something that will speed up your query at very large scale. You won't have to scan all data, but just the part of data that is required. So that's why partitioning is a big feature that was demanded by the community and we delivered. Other than that, we also support all the catalogs. The reason is data engineering as an industry is completely moving towards Apache Iceberg. Many companies and major MNCs are adopting it. So it made sense to support all the catalogs because Iceberg runs with a catalog and we support Glue, REST, JDBC, Hive. Inside REST catalogs, we have types like Nessie, Polaris, Gravitino. We support all of those as well. The next feature, like I just mentioned, you can easily go and set up Kubernetes on OLake. The repo links, the YAML files, configurations, every detail, every inch of detail you need will be in the documentation section. Just head over to docs, install, and Kubernetes installation section. So just preparing you the agenda of this meet, I'll just show you very quickly in 10 minutes how to sync data from a source, maybe a Postgres, to Apache Iceberg format using the Glue catalog. Once the data is in there, I'll show you how it went there, what partitioning did we perform, how the partitioning actually works. The third will be to, okay, someone just joined, so give me a second. Okay, Jack is also with us. Hi, Jack. Glad to you joined with us. We were just discussing about the agenda of this meeting, what we're going to show you. So you can just access the recording of the meeting. I'll be posting this on our Slack channel for the things that you missed out, but just believe me, you did not miss much of things. So again, getting back on the agenda, after we dump the data, I'll just show you using Athena a very quick query on how the data is looking on the dashboard. And then I'll just give it the dashboard or give it the platform to Adish. He'll just show you how he used OLake at his platform or at his workstation. So I guess before we proceed, if anyone has any information or any doubts, please feel free to raise their hands. We'll be happy to answer. Or if someone is wondering like why we're having this meetup or want to introduce themselves or want to understand who we are, what we do in a brief introduction, if you're joining us for the first time, feel free to just raise your hands. Okay, great. So I think we are ready to proceed to the next sections. And yeah, a big announcement. OLake UI will also be there in a couple of weeks. So just hang on. After we are done with the demo, I'll show you the UI as well, how it looks like, how you can configure jobs, add sources and destinations. So if you're interested to that, just stay till the end of the video. So let's start with the demo. So for the demo, I have prepared, yeah, great. So I guess if you have reached till the 6th community meetup, you will be having little knowledge on what OLake is, what we do, or how to set it up. So even if considering you are the first time joiners and know and do not have much about what to do, how to do, you can go to our getting started section. We have listed if you have a database like Mongo, how to dump from Mongo to S3 or Iceberg format, MySQL to Postgres, MySQL to Iceberg, or Postgres to Iceberg. So just follow along. You'll have a TLDR of what things you need to do. Just wait for a while. Okay, Azim also joined here. Hello, Azim. Glad you are with us. Coming back to the presentation. So we'll have a quick TLDR at each of these getting started documentation on what to create, what to run, and okay, we have another meetup. Pranjal. Okay, guys, I'm sorry for the interruptions, but we have few people still joining us. So, hi, Pranjal, welcome to the meeting. Great. So basic TLDR for syncing any database to Iceberg is creating a config.json, creating a writer.json, running the discover command, and running the sync command. So basically, are the 4 steps you basically need to do in order to move or replicate data from A point to the B point. Below is a GIF file, which basically shows how easy it is. Like just run one command, the Docker one or the build one, cover the streams catalog section, then sync data from point A to point B, giving the path of those files that you created, which are the writer and the catalog JSON files. So we have Mayur Sarkar. Hi, Mayuk. Glad you can join us today. Okay, great.
Hi, Priyank. Feeling good to join.
Yeah, likewise. So we'll have a Q&A round at the end. So just hang in for a while for all the people who have any questions. Great. So let me just go back here. So this is the sample config file that you'll be creating, which this is for the Postgres one. You'll have to need to fill the host, support, the basic information, database name, username, user files. So if you're not sure how to fill those up, you can just go to our sources, Postgres or AnyDB, and configs. You will have a list of parameters, the description, and example values. So for this demo, I have chose a sample DB. The credentials, of course, will be hidden for you for now. After you run the discover command, like I'm going to run it right now. So for that, I've prepared a command.txt just for easy access, so I don't have to write comment or write the code in front of you. So basically what this does is it basically takes the config details or the absolute path where the config.json lies and runs a discover command on them. So nothing fancy. Descriptions of all the commands will be in the docs. So just you don't have to worry about it. Just go here, move everything and paste it here. So right now it's discovering. If you see something like this, it means that your discover command ran successfully and it will create a catalog.json file. So for now, I just have to go and format it. It will show you basically what all streams or collections or tables are in your database. So in my public database, we have customers and sample data. And basically the below section shows you all the properties or the column and their descriptions. Like CDC timestamp is an integer, OLake ID is a string, created at the email is of type string. So basically, this gives you a schema of your database, how and what things are there in your database. So what you need to do right now is, because we are demoing our Iceberg partitioning feature. So let me just go back here. Partitioning. So inside destinations, Apache Iceberg and partitioning, you will find a detailed documentation on how to set up partitioning regex or the partition of what you want your data to be formatted at the destination side. So suppose you want to partition by date, or suppose you want to partition by maybe the first name, if you have a bunch of first names, or suppose you want to partition by bucket names as well, or bucket types. So all these use cases are covered in this detailed documentation, but for this demo, I'll just show you a basic use case and we'll see the data being written on Apache format in the ICE3. So Anas also joined us. Yeah, hi Anas, I'm glad you could join us today.
Hello, yeah. Thank you so much.
Yeah. So just hang on for a while. We were just demoing our new Iceberg partitioning feature. We'll be taking questions at the end of the session, so just hang in for a few minutes. Great. So inside the catalog.json, you'll have a partitioning regex field. So let's suppose this is my customers table, and inside I have a first name. So I want to partition by first name. The format for that can be like first underscore name. This is the first field goes for the column name, and the second field can be identity. So if you're not sure what identity means here, you can again just refer back. So this is the syntax basically. The first field is the field name, the column names, and the second is the transform. So Iceberg supports like 7 or 8 transform functions. These are identity, year, month, day, hour, bucket, and truncate. So if you want, you can also do something like created at and then pass in the year name or the day name or the month name. Yes, you do like this, and then you create again one regex where it says created at okay, yeah, created at day, and then one more like created at or by first name, etc. So just play around with this regex. We support almost infinite number of partitions that you can create, but if you come up here, we'll have shown you, we have given you examples on, suppose if your use case is X, perform or use this partitioning regex. So if your use case is Y, like global e-commerce orders, so this can be a kind of start for you to partition your data if you're not sure which or how to partition the data. So let's go back and I'll just use the basic ones, first name, and let's say identity. So what this identity basically will do is, just let me go back. Yeah. It writes the column with, you should use identity on a column which has distinct values and very few values, suppose like country or date. And we are using it here because we have a sample data of 6 or 7 columns with just their first name all being unique. So this would be a good start. And if you do not want to sync all of your columns, you can just go ahead and just remove this stream from your selected streams. This is just basic functionality of our OLake CLI. When we have our OLake UI ready and up and running, you won't have to deal with all this JSON editing and stuff like that. So now that our catalog.json is ready, I'll just go ahead and run the sync command. So the sync command is basically same as the discover command with little differences. We write sync over here. We give the config files absolute path. We also give catalog paths absolute, catalog files absolute path, as well as the destination where we want to write. So in this case, I want to write to S3 in the Iceberg format. So if I go ahead and show you what it looks like, it will have the catalog type will be Glue, of course. You can also have Hive in here or REST in here and pass in the appropriate configs for those. If you want to know more about which all configs are there, how to use them, you can go to destinations, Iceberg, catalogs, and we have configurations and details of those configurations written over here. So I'll be just using the Glue catalog for now. Let's Glue. We have turned on normalization as true. So, okay. Harsh Gupta has joined us. Hi Harsh, glad you could be here. Great. And then you need to specify the path where your data will be dumped. So in this case, it will be S3 OLake test Iceberg. This is the name of my bucket, and OLake Iceberg. The AWS region, the access keys and access secret keys are hidden for security purposes, and the name of your Iceberg DB. So if you have this setup, you can just go ahead and check that you have the necessary IAM permissions applied to your account. So this is something which users may forget. So just keep in mind, you need all these permissions to be able to sync data to your S3 table, sorry, S3 or in Iceberg format. So just go back. I've copied the command, just copy the sync command, and I'm going to run it. It will take around 30 seconds to a minute, even less in some cases, depending upon the number of data you have. Because since I'm just using some sample data, it will be done in like about a minute or so. So yeah, these are the logs. And one feature also that was requested by the users was to have logs saved somewhere. So right now it will be written on the directory where you have created your config file and stats file. We are in process of dumping these logs over your S3 as well. And in the UI, it will be shown to you in the UI console directly. Great. So it's total says total record grade 5. So now just let me show you where this records got written. So this is my S3 table. And if I just refresh it a bit, right? Inside OLake Iceberg, OLake test DB, you will see customers. So the name of our database was, got it. Yeah, customers. So the file got created over here. Inside we have a data and metadata. We just need the data part. And yeah, because we did the partitioning using first name and identity, it basically created partitions by first name, Fiona, George, Ivan, Hena. And yeah, you'll have all the Parquet files inside. And if you want to visualize what these Parquet files are, you can just download them here, use a Parquet Explorer or over internet, that's on you. But now let me show you on Athena querying this data. So if I just refresh over it, I have my Athena console already open. You can go and select the database from this list of databases, and you'll see the table created over here. So just let me show you the entire table. This is the entire table data. Again, I'm just using a sample to show you how the partitioning was done. And let's see where first name is Ivan. So because I made partitioning, or we made partitioning based on the first column values, let me just run it over here. Okay, I just need to remove this. Great. Great. So it did show you this is the OLake ID. We basically derive OLake ID based on the primary key, the hashed value of primary key over here. They created at, updated at, and the account ID. So the thing to note over here is the data scan thing. So you'll see it took 0.53 KB data to be scanned to show this result. So suppose you were working with like 100 TBs of data or 100 GBs of data. The data scanned in that case, if partitioning is done right, based on the columns that are most important to you or your queries, you'll see a significant decrease in the data scan values. So I'm not like a data engineer, but I can show every engineer or every data engineer knows how partitioning helps in reducing the data scanned and increasing the query time of the speed of the query time at the bottom. So that was a little demo from my side. So now I'll just hand over the mic to Adish. He's been working with PhysicsWala and a data engineer 3 at there. So we got into a call with them, and they told us that OLake is kind of a rising hope for them because they used to use Debezium and faced a lot of problems with those infrastructure. So Adish, over to you. Feel free to educate us on how OLake helped you and what are your use cases with OLake and things like that. So yeah.
Hey, thanks, Priyansh, for introduction and for briefing the progress of OLake over the past few months. And like I've been in touch with Shubham from like it's around 3-4 months now, right? When you started, and we have shared a lot of problem statements, and happy to see that OLake is now running in production, and we have catered a lot of use cases that we have discussed from back then. So I'll just take over the screen. Hey, Rohan, you too. Okay. So let me know once my screen is visible. I hope the screen is visible.
Yes.
So this is something about the collaboration that we have with OLake and PhysicsWala. So we'll be covering a few things. First, we'll move to the data infrastructure and the journey that we have in PhysicsWala. Then we'll move on to how we are using Debezium for CDC and for ingestion from several sources. We have Mongo and SQL Server majorly. Then we'll move on to the challenges that we have faced with Debezium. Then back to the topic of OLake now, like how OLake is solving our problem and how they have catered the challenges that we have faced with Debezium, and they are very interesting features in OLake that actually resolves most of our problem that we are facing in production as of now. So this is the brief content that we'll be covering. So like just to give like set a context, like going back 2 years in PhysicsWala, we used to have a data warehouse sort of architecture where we are dumping everything into Redshift. There we were building some models, or you can call it mat views and views on top of Redshift. But we faced a lot of issues there because with Redshift, we usually have slow bulk loads. Then we don't have the capability for real-time ingestion, as Redshift does not seamlessly supports real-time writes, right? Then we have query performance issue when we started to scale our system in Redshift. So these are some like scale and cost, and again the performance related challenges that we faced in Redshift. Then we actually migrated everything to Lakehouse architecture, where we have actually decoupled storage and compute part completely. So everything now resides on S3, like most of our data. So this is the high level architecture of how we are catering the data use cases at PhysicsWala. So if you see our major use cases, sorry, is there someone joined or? Okay.
No,
Yep.
Adish, I was just sharing some docs with the
Okay.
community.
Sure. So, yep. So I was just going through the high-level architecture of how we are doing things in PhysicsWala. So we have our major sources in Mongo and Kafka majorly. So Mongo plus Kafka combined to around like 90% of our data that we have in PhysicsWala. Then we have other sources like MySQL, Postgres, Google Sheets, and then there are some sources that includes SQL Server as well. So just for the ingestion layer, we use a mix of open source in-house and some paid services for our tools that we are having in PhysicsWala. So right now, we are leveraging Spark for both ingestion and processing of data across all the layers that we have here. So if you can see, we have bronze, silver, and gold. This is the medallion architecture that is also common in Databricks ecosystem, but this is completely built in-house at PhysicsWala. So in bronze layer, we usually dump the raw data without any transformation and anything. This is just what we have read and we have dumped it here. And then we again have Spark jobs. So these are both batch and stream jobs that gets the data from bronze and dumps it into silver. So in silver, we curate the data a bit, apply some transformations, maybe data quality checks. Then we have some auditing mechanism, which gives us insights on how many events are ingested. If there is any drop, then if there are any thresholds or where we can actually look into, right? Then the gold is mostly reserved for analytical purposes. So we have data models, mat views, and views inside gold table. So mostly exploitation layer restricted to silver. And then again, for analytics and downstream consumers, you have the gold layer. If you see, we have mostly used Airbyte, Spark, and Iceberg. So these are mostly open source tech that we are using right now. On top of that, we have some in-house tools that we have built. So we have Dataset API. It's, I think, the small part here. So Dataset API. So this is basically the governing layer on top of everything. So here we stores the source and destination metadata. So this is basically the dataset onboarding part where we onboard the dataset via via API. So this contains, let's say we are onboarding a Mongo dataset. So information regarding Mongo and like which Mongo, which cluster, which collection, and the information regarding the destination. So if we need Iceberg as a destination, then we'll have to put Iceberg. Then in what table do we need this data? So these are the things that we can mention in dataset API. Obviously, the partition and these low-level information can also go in, and rest of the thing can be taken care of by the central data platform that we have. So these are different tools that you see in this HLD, but these are all integrated in one place. So we have a framework called CDP. We call it Central Data Platform. So all the tools that you see in this box are integrated tightly, and they can actually fetch the data and communicate with each other. With Spark, so gets the data from Dataset API. It learns that this is the destination, this is the source, and we'll have to send this data to this layer. So this is how the complete infra is working as of now. Then we are exposing, as I mentioned, the exploration layer resides on silver, and then we have the downstream consumers on gold. So this data is exposed on both Redshift and Trino. If there is any use case in Redshift, mostly it is exposed to Trino. Trino is again a query engine that we are using. One more thing that we have incorporated here is that we completely use the shared resources via Kubernetes. So all the applications that are deployed are on Kubernetes. So for Spark, Airbyte, Airflow, Open Metadata, Hive Metastore. So everything is on Kubernetes, and they are sharing resources. So we are actually saving a lot of cost in terms of performance. We are also leveraging Kubernetes scaling capabilities. That's like container based, and we scale up containers as and when we want. So this is the high level overview of central data platform that we have. Then we have another in-house tool that we call Lagoon. So Lagoon is basically the scheduler that works or orchestrate all the parts of this diagram that we are seeing here. So this is completely config driven sort of framework. We will be passing some configuration like some YAML files, which tells which layer has to be populated with which data, what it should be the schedule interval and all. So everything goes inside this rapid scheduler part. It passes those YAML files and generates Airflow DAG for us. So we don't have to manually go and write Airflow code for every data set and schedule it. So Lagoon takes care of that. It also interacts with the dataset API that I've mentioned here. So it basically fetches all the information from there and schedules our DAGs accordingly. Moving on to the Debezium part. So as I've already mentioned, like most of our data resides in Mongo, and it's always better to read oplogs rather than directly querying collection. It has its own caveats. So we land up on Debezium to cater our use case. So Debezium obviously comes in three flavors. Two are mentioned here, which are widely used. So one is with as a connector in Kafka Connect, so which is what this diagram shows. So we can have multiple connectors in Kafka Connect, listening to a particular database or maybe the deployment in MongoDB, and it streams the data directly into Kafka. The other version that Debezium has is a Debezium server. So there we have like a standalone kind of deployment of Debezium, where we can deploy a container of Debezium, which again does the same job, tracks a particular deployment, and streams it into Kafka. With Debezium server, we have one more benefit is that we have multiple options of dumping data. Like apart from Kafka, we can use Google PubSub and all. So this is how Debezium would work in our scenario. We are again deploying this thing on Kubernetes and have a container for each of our deployment. Sorry. Yep. So there are some challenges that we faced with Debezium like over the past, we can say 1.5 years. So one thing is like complex schema evolution, because we are actually consuming a lot from MongoDB, and by nature MongoDB is schemaless, and there are a lot of use cases where the schema is schema evolves, and we don't get to know if there is any new fields gets added. We have to write a lot of custom logic to track those changes and rebuild our downstream tables. So that is one part. Although Debezium has this capability to connect with schema registry, but again, for that we'll have to write a lot of custom logic to handle that changes, and it again has a lot of caveats there as well. With Debezium, we cannot directly ingest our data into a data lake or a lakehouse, because it works in a way like it is tightly coupled to a message broker system, where we have to have either Kafka or some message broker in place, so that the events can be streamed to that message broker, right? Then we have incremental snapshot problem. So although Debezium has the support of incremental snapshot, we have to have a separate setup for that. So with Debezium, they have a concept called signaling. So if there is a deployment running, we'll have to set up some signaling thing in the production, so that we can signal the deployment to have the incremental snapshots. Again, as I mentioned, Kafka is a must here. Full loads are especially very slow in Debezium if we have some collection with over, let's say, 10 or 20 million of data. So the full load takes a lot of time to complete and then start its CDC part. Then there is one more issue of handling heterogeneous arrays with SMT. So with heterogeneous array, I mean Debezium is a Java-based tool, and the arrays that we define in Java has to have like the same data types in them. So that is the limitation in Debezium. We'll have to convert those array into objects or map to accommodate the Mongo schema, right? So this is again a problem for us, as we have to change back these objects back to array for downstream consumers and all. And again, a custom logic has to be in place for this. There is no resume option in full load. If for some reason our full load fails at some point, there is no resume option that we can have. Okay, the last one, I think this is copied here, but I'll just walk you through the last one. So there is one more issue with Debezium, is that by nature, Debezium works in a streaming way. If we need some batch jobs, so we don't need the complete CDC, we just need to ingest data from Mongo at a particular interval of time. So Debezium is not made to work in that way. We'll have to manually stop the Debezium job, then restart it again. So this is how we'll have to have a workaround for that, but there is no out of the box support for batch jobs. So that is one more challenge that we have with Debezium. So if we are using Debezium, we'll be streaming the changes which may be needed at a particular interval of time. So there comes OLake again. Like we discussed these challenges with OLake team a couple of months back, and they have actually catered a lot of uh, challenges that we have faced. And as of features in OLake, we have almost overcame all the things that I have discussed, be it schema evolution, and also I'll be discussing the some features that actually we are leveraging from OLake. There may be more, because even I have not explored OLake fully. So for schema evolution, so OLake actually simplified the schema evolution. Whatever changes that we have, new columns, new keys, and complex types, so everything is taken care of OLake without any need of like manual intervention. We just have to set a property called normalization from false to true, and it takes care of that. Then there is a direct ingestion from source to Iceberg. So this is the idea of OLake. Maybe they'll be adding the feature in the future for Kafka and other message brokers as well. But right now, this is actually solving a lot of problems for us, that it directly ingests data from source to Iceberg, which is our Lakehouse format that we are using right now. Full load capability is configurable. We can have either full load or CDC events in our Iceberg tables. Then there is zero dependency on Kafka that has already been discussed. Handles complex data types. So OLake provides this functionality of converting this complex type that we have discussed, that in DBGM we have to convert it into map type. So OLake sends these complex type directly as a string in our downstream system, which we can handle later on, which is a big time saver for us. Then this is a very good feature of fast and resumable full load. So the full loads are actually very fast in OLake, as we have observed, and the resumable full load feature. This is something that we have not explored as of now, but this will come in handy when we are ingesting a big data set, or we are performing a full load on a very large data set, and if for some reason, for memory issues or any other reason, it fails, then we can actually resume it from the point where it failed. Whereas in division, we'll have to do the whole thing again, right? Partitioning is something that I think we have already seen and discussed. Priyansh has already shown you the demo of partitioning on Iceberg. So this is something cool that we'll have in OLake out of the box, and we'll not have to take care of that in our downstream consumers. So this is something that I really liked about OLake, and the features that we have used in PhysicsWala. Right. So moving on, we'll have demo section. So obviously I cannot show you the exact ones that we are using because of the keys and all, but I've put it in the slide just for your reference of how we are using it. And this is something that Priyansh has already displayed earlier. So we are breaking it down in 3 parts. So one is writer config, one is source, and the last one is catalog. So writer is you can map it to destination thing. So how we map it to destination, we are using the catalog type as Hive. So Hive for Hive Metastore. Normalization is true, that I've already discussed that it will cater all the schema changes and bring in data with the schema. We'll have to pass in the warehouse path of Iceberg, then Metastore URI that we have, then access keys or secret keys that can pick it up from IAM roles as well. But just for the simplicity, I've put these properties here. Then some SSL and path related other properties that we have a very good, I think, documentation in place. We can go through all these properties. The main things that I can discuss is that Iceberg DB. We'll have to just mention the DB name, Metastore URI, Iceberg path, normalization, and catalog. So these are the main properties that we can focus on. Then we have the source config. We'll have to pass in the information regarding the source that we have, like let's say in our case it's Mongo. So the host of Mongo, username, password, or DB. Read preference would be like, let's say we just want to read it from secondary. If it is the SRV string or not, then we can put SRV as true. Then server RAM and all, if we want to define it here, but I guess if we are deploying it on Kubernetes, we can have a pod template where we can define the resource limit and guarantee, right? The max thread, so this is something that is actually useful in chunking the data. If we have a lot of records in a particular collection, we can increase the threads for faster loads. I'll keep it as 2 because I'll be demonstrating a small dataset load that only has around 50 lakhs record. Then we have default mode as full refresh CDC, but we'll put it as CDC. Then this is the retry count. In the catalog conf, like this is also something that Priyash have already displayed earlier. So just to make it simple, so we'll have to pass in the collection that we want to be ingested. So this comes inside the selected stream part. Then this in this stream part, all the metadata regarding this collection will come. So if you see in the selected streams, I say that this is the DB name, PW community 2, and then some information regarding the partition and all, how will you want to see the data in Iceberg, and then the collection name. So this is the likes. Then in stream part again, we'll have some metadata regarding the collection that we have. So I think Yash has already walked you through all these things that we have in stream part. So, and one fun part is that you can generate this catalog part using a command that OLake provides. So we do not have to write this thing. This may seem a little bit complex, but we don't have to write it anyways. Yep. So now the demo time. So I'll be using staging collection that we have. So this is the collection that I'll be loading into our Iceberg warehouse. So this is the likes collection. We have around 15 lakhs records inside this collection. If you want to see how the data looks like. So, okay, I think we have to log in again or okay. So this is how our data looks like. So the thing sensitive, we can go over it. So lots of IDs and the name. So this is all the data is about. So we can see only like in the few records, the post ID created, updated at then user, it's an object with name and ID. But I know there are more keys in this, so that we can see once we have ingested this data into our Iceberg. So we'll actually see the schema evolution in place as well. So I'll be using the configs that I've just displayed, and we'll be doing it on again Kubernetes. So this lens that I'm using the UI tool for Kubernetes. So we have already set up these 3 writer configs. Obviously, I cannot show it because of the keys and all. So writer config that we have already discussed, I've shown you what is the formats, and I'm just keeping the same thing here. Then source config, then catalog config. So all these things are set up here. And then we have to create a cron job. So cron job is created here, and just on this cron job, we'll see. Okay, it's maybe locked out. Just reconnect the clusters. Okay. Cron job. Great. So it came up here. So it will take some time to launch the pods and pull the image of OLake. So it may take a minute or two. It is finding a node to schedule it on. I think we have the node. Volume is attached. Okay, so the init container is running right now. And after this, we'll have the actual container running. Great. So it is pulling the OLake image now. Yeah, I think it got succeeded. Let me just check on the OLake folder. So we have the like still. We just check the record count that we have. So in the likes, we have around 1507610 records. So around 15 lakhs record that we have in likes. Check it out here. Okay, so we have the 15 lakhs that we needed. If you see the data, yep, the data is replicated as it is. So as I've mentioned that initially we like for the first few record we have only seen the user post ID created and updated at in the table, but for some record it may have comment ID and reply ID as well. So these columns are added, and like maybe for these records we have null comment ID and reply ID, but during the full load it gets automatically added, and we'll just have to see if any schema evolution doesn't happen here. So let me check if we have any comment ID is not null. Sorry. Schema like okay, I'm running it on prod. I'm sorry. Yep. So we can see, yeah, so these comment IDs are here and our schema evolution is working as expected. So, yep, I think that is it that I wanted to share. Maybe Priyansh, Shivam, you can take over from here. Thank you.
Yeah, thank Adish for this presentation. Like I see a lot of hands clapping emojis on my screen right now. Yeah, Kshitij, Merlin, Vladimir, Azim, Praneeth, Tarka, Vikash. Okay, guys, that's good. We can move forward. So ready to open for any questions. If you guys have, just feel free to raise your hands. Else, we'll move with the last part of the presentation. So just waiting for you guys. if there is anything or anyone. I have noticed Vladimir joined at midway of the session. Few more folks joined midway of the session. So yeah, guys, if you have any questions, just feel free to reach out to me.
Okay, Ansh, this session was very helpful. I have a query. So while loading the data from source to destination, what is the processing language or tool which you use from connecting to the source to the destination?
If I understand,
Let's suppose currently for the EL we use Spark for the connection source and destination, right? In the OLake, does it use any pre-available source tools, or you have built entire new system from the loading data from source to destination?
Shubham, would you like to take this up?
Yeah, sure. I'll just take it. Basically, we have built the whole new framework for syncing the data from source to destination, because what we have realized in the previous products and everything that we have done as a company, there are not really good enough ELT or EL tools out there which helps you to send the data from all of these databases to lakehouses in a really fastest way possible, because lakehouses are different than data warehouses in a lot many ways. They they have a lot of catalogs. They do not have like actively running process, and it's been it's been the scenario that industry is actually moving towards lakehouses. So we decided to design it fully from the scratch to leverage like the best way possible to dump the data from databases. So we did it from scratch.
Got it. I'll go to the code base and documentation. I think you have said it. But before, what is the language you use for this movie?
We are using Golang for now, and our currently Iceberg writer is in Java. Like we primarily use Golang to pull the data. We write it using a Java Iceberg writer, but we are planning to actually move to a Golang-based Iceberg writer or Rust-based Iceberg writer to even boost the performance by a further margin, because we feel that Java is a little heavy on the memory footprint side.
Got it. Yeah, Golang Iceberg is a writer is also now getting popular. We have acted. Okay, got it. Thanks, Shubham. I'll go through it later once I can get done. Sure.
Thank you. Guys, any other questions? I'm happy to take any questions that you might have. Right now, like as just Priyansh mentioned, right? Priyansh, if you can give us a little quick walkthrough of the UI that we are in the process of developing.
Sure. So
And, huge shout out to Swati and Ankit and Vikas. They have been working really hard on this.
got it. So Shubham, there's a question from Vladimir. Like, would you be demoing the transformation aspect of ETL? So if you can talk about the kind of transformation that we do if we do it.
Sure. So there would be two kinds of transformations. Like one is kind of a SMT, or the transformations while you're ingesting, which is more or less like the ETL. So we'll be introducing some features like filtering and some level of like minor, not really heavy kind of a coding kind of a features on the ETL side, where you can transform the data even before it's ingested, like maybe changing some data types, or basically doing some level of date like date format changes and all, and filtering as well. But then there would be a heavy level of transformations which would happen after the data is ingested. So we are primarily following the ELT model, where you can actually transform using any of the frameworks like DBT transformations and other sorts of things.
Great. And yeah, as Rohan mentioned in the chat, like we'll also be releasing benchmark reports soon. We have an initial benchmark for MongoDB. You can go check out our GitHub repository for that, and more accurate Postgres and MySQL based benchmarks will be coming soon. And just a sneak peek, it's like faster in terms of like 1 digit to 2 digit numbers. So you can expect some great performance from the open source tool we are building. So okay.
Sorry, just one thing I would like to add about the question. Maybe I have not clarified, but SMT kind of that mid-level transformation feature is yet to be launched. We are still, it's in our roadmap. Maybe it could be launched in 2 to 3 months, or maybe a couple of months as well. Like it's in our roadmap. Thanks.
Okay. So talking about the roadmap that Shubham just mentioned, so let me share my screen. We also have Great. So if you go to our GitHub repository, GitHub datazip-inc OLake, if you head over to discussion section, we have an OLake discussion build over here, in which we have added what is our roadmap for Q2, what is our roadmap for the following quarters. So if you feel we need some kind of more features into it or something that you would like to see us building, just comment down below. We have planned additional sources based on Kafka S3, but these are all based on community requests. We also have an issue regarding a heartbeat feature. You can just click over here and go to the issue and check out what we mean by that. Other than that, we are planning to add more schema evolution like handling deletes, creation of new tables, changing columns, etc. Then again, writer improvement, just now Shiva mentioned, like Rust-based Iceberg writers and things like that. So just feel free. Okay, there's something. Okay. Or you can, yeah, thanks, Sai. Great. Now moving ahead with the presentation. So great. So the demo from Adish was great. Now ahead, we also have written content around deep dive into OLake architecture. So in this blog, if you just head over to olake.io/blog, you will see an article which talks about OLake architecture, the core framework, the writer's destination, what we do, how the data flows into OLake, the chunking strategies in Postgres, the parallel process implementation and its optimizations. So just feel free to take a look at it. The links will be shared in the groups as well, the Slack community that I think most of you have joined. If you have not joined, just click over this Slack button and you will be redirected to our Slack community. Other than that, for contributors, you can just use this doc to see how to get started with OLake. For data engineers, it's understanding OLake's edge, what we do differently that makes us faster. And for decision makers, what benefits OLake provides us in terms of TCOs, like total cost of ownership, how you can implement OLake in your infrastructure or replace some systems and integrate OLake as well. So that's for this blog, which was one of the most requested blogs from our community. So feel free to check it out. And that this is about the roadmaps that I just showed you. So let me skip ahead. And the biggest thing that we got was contributors. So a huge shout out to all the contributors. I believe some of the contributors are on this call right now. So like Aditya, Lalit, Sanket, Varun, Hardik, and Kavya. So these were the contributors that helped OLake ship features in a faster way. So huge shout out to them as well. We'll be sending goodies to them as well as your PRs get merged. I'll personally reach out to you and you'll receive some kind of thanks from our side for your contributions. And for the people who are on this call and are looking to contribute, you can just head over to our contributing docs in the repository. So over to contributing.md, or if you want a detailed one on the aspects of what we do not do, just go to community section and contributing. The reason that you should contribute to OLake, like I can point out a few here, but that depends on how you want your career to progress, or it's not like a new thing. If you're in college, it's a great time to contribute. If you're in college, contributing to an open source gives your resume an edge, which every recruiter wants to know, that if you've worked on a real-time project, a project that is being used by real companies, if you have that in your resume, it will definitely helps you very well. And the second part being Go is in-demand language. We do hire for Golang developers every now and then, and the market is like needs more Go developers. So it's a good language for open source projects, and it's a good time to be in open source market and learn language Go. So those were the things. Now let me show you the UI. So if you have been with us this far, let's go back. Share. So I hope
it's a sneak peek. We don't have it like published as of now. It's a great sneak peek. Yeah.
I hope my screen is visible. So this is the basic draft version. Yeah. So we have sources, destinations, but the major thing is we define is around jobs. So if you see on my screen, we have a job name, source, destination. So what jobs actually mean is you connect a source to a destination and you make the sync frequencies or configure the cron configurations, and that is called one job. So how to create a job actually? So when you click on create a job, you'll see UI like this, where we can Postgres, MySQL, Mongo, just fill in the details. The docs will be on the right hand side for that reason. If you hit create, it will just show you some test your connection. If it's successful, it will move to second screen. Right now it will be success because we're using some dummy data over here. And then on the destination side, you need to set it up. If you want to just sync to S3, select S3. If you want to sync to Iceberg, select Iceberg. Will ask you for all the catalogs. Which catalogs do you want to sync with? If it's Glue, or if it's REST, or Hive, or JDBC. Again, what you need to fill inside here will be present. Okay, just let me, yeah. The details, what the format should be, Iceberg, the catalogs, the username, the password, etc. will be over here as well. And then when you click next, it will again test your connection. If it's right or wrong, it will give you errors like these are values allowed, these values are not allowed. Then you will see a stream section, stream selection section, where you can have CDC mode or full refresh mode for sync modes, if you want the backfill or not, if you want normalization to be turned on or not, like how Adish mentioned, we support that feature in the UI as well as in the CLI. So this actually, let me go sample. Yeah, normalization true or false over here is equivalent to this section over here, true or false. Then you'll see the schema of each table, which all fields it does have. Then the partitioning feature as well, select the column you want to, enter the default value and add. So all these features will be refined according to how the OLake CLI works right now. When you hit next, you will see, let's give you a job name or infra data replication or something like that. Then set the frequency, the seconds or minutes, hours, whichever you want to do it. The detailed docs for this will be released once we release the OLake UI. And then you can select when you want to propagate, when field changes are there. We'll add more options for you to select as well. And when you hit on create a job, it will say, yes, your job is running successfully, etc. And you'll see a job over here. So this is a basic sneak peek view. If you want to contribute to this UI feature as well, you can just head over to OLake. Okay, not OLake IO. It should be OLake UI. Yes.
Just your screen is stuck on that demo.
Sorry, let me just share the entire thing. So I hope you guys liked how the UI is coming along. We still have a long way to go, but yeah. If you go to datazip inc/OLake UI, you will see the code thing. We have not yet merged everything on master. You can just go to the initial setup branch or the other branches where you are working, like the staging branch or the server branches, etc. So yeah, that's it for the UI part, and we are open to questions. If anything you want to discuss, or what made you join this call, or what things you like about OLake, or how you want to contribute to OLake, just feel free to reach out to us. I see a lot of faces right now over here. So if it's possible, you can just turn on the video for once, because this marks the end of the presentation. Yeah, Merlin, Sandeep, the entire OLake team is on this call. Swati is basically working on the UI stuff. Titish is our DevOps person. Akash, Akshat here is the designer guy that designed the OLake UI. So this is the entire team. If you ever was wondering who the people behind OLake are, so these are the folks right now on your screen. Let me just take a quick screenshot. Yeah, hi. Yeah, thanks, Vladimir. Got to go. Great. Yeah, thanks, Vladimir, for joining us. So we are right now around 122 odd members on Slack. This has been a great month for us. We are moving in the right direction because the users keep on saying to us, like, yeah, this is a real problem that they have, and it's good they are supporting OLake. So if any one of you who are not on OLake Slack, just feel free to join it. We'll be releasing the video recording of this call, the features that we release, the connector versions that we just released today, the new release we have, and all the things related will be posted on Slack. So if you're not there, just feel free to join. Again, shout out to our contributors. Thanks for the contributions, and you'll be receiving a message from me today myself.
One special shout out to Adish. Thanks for the presentation and the really exciting demo. We hope to work with you and try to solve all the problems there together.
Adish, it would not have been possible without you.
Thanks, Ron. Also excited for the features that we'll be releasing so that we can actually leverage it for more data sets.
Thank you.
So,
Thanks, Adesh.
Yeah. Thanks, Adish. So I'll just wait for 2 more minutes. If anyone has question, just raise up your hands or just speak directly. Happy to answer. Or we'll just wrap up. It's been like 1 hour, already 1 hour for us. So. Great, guys. Thank you for joining. We'll be soon posting about the future meetups or what we have planned, what we'll be presenting in our meetups. Basically, we do these meetups bi-weekly or 3 times a week or 3 weeks in a while. So yeah, just keep on having, keep on looking on your Slack notifications for a message from my side. So thank you for joining. I hope you have a great day. Thanks, guys.
Thank you. Bye.